In the previous video, we have discussed searching algorithms. We compared the performance of linear and binary search algorithms, and we said that binary search algorithm performs better than linear search in terms of the number of iterations it takes for the value to be found. In order for the binary search to work, the list must be sorted first. In this video, we are going to discuss how we can arrange the values in a list in ascending or in descending order. Specifically, we will discuss two sorting algorithms, the selection sort and the bubble sort. When sorting items, we usually start with the first item, then we check the value of the second item, and then we decide whether to put it before or after the first item. Then we take another item and put it in a certain position, ensuring that the sorting is maintained. We do this until we exhaust the items in the list, and the list is sorted. But in Python, we could simply use the sort method or the sorted function to sort lists. Let's see what these functions do. For instance, we have a list containing several items that are not sorted. Let us use the sorted function in sorting this list. The sorted function returns a list containing the sorted elements of the parameter, in this case, list 1. However, if we use the sorted function, list 1 is not modified. If we print list 1, we still get the same unsorted list. The sort method, on the other hand, modifies the list, making the values in it sorted. Here, list 1 was sorted when we used the sort method. For ComSci 12, we will discuss two sorting algorithms, selection sort and bubble sort. Selection sort iteratively finds the smallest value in the list. The list has two parts, the sorted and the unsorted parts. The smallest value is searched in the unsorted part and it is added at the end of the sorted part of the list. Let's use selection sort to arrange this list in ascending order. The first step is to find the minimum value. In this list, the smallest value is 1, and then we swap the minimum value in the first item in the unsorted part of the list. Since this is the first iteration, the entire list is actually the unsorted part. So in this case, 1 is already sorted. Next is to find the minimum value, which is 3, and then we swap the minimum value in the first item in the unsorted part, which is 7. 3 is in the sorted part of the list. Next is to find the minimum value again, which is 5, and then swap. 5 is sorted. Find the smallest value, which is 6. Swap 6 and 7. 6 is already sorted. And then since 7 is the only one remaining in the unsorted part, 7 is also sorted. Here's the Python implementation of selection sort. The two operations are finding the minimum value and swapping the minimum value with the first item in the unsorted part of the list. Let us run this in the Python interpreter. So this is your selection sort program. We have a list, and then for each iteration of the selection sort algorithm, we will just print the current status in order to see how selection sort arranges the values in our list. Let us run our program. So this is the current list. This is the input, the unsorted list. And then for the first iteration, since the minimum value is 0, it is put at the start of the list, and 0 is already sorted. For the next iteration, 1 is the minimum, 1 is sorted, and then 2, and then 3, followed by 4, 5, 6, 8, 9, and then finally 10. We can modify the code to sort the list in descending order. Instead of looking at the smallest value in the unsorted part of the list for every iteration, we look at the largest value. Let's modify our program. So in our selection search function, instead of checking if the current position of the minimum value is greater than the current item, we change it to less than. Let's save and run our program. So this is our initial list. 10 is the maximum, so 10 is put at the beginning of the list. 10 is already sorted, followed by 9, and then 8, and then 6, followed by 5, 4, 3, 2, 1, and then 0. That is our list sorted in descending order.